So, hello friends, welcome to my YouTube channel Investments. In this video, I will discuss real analysis basic, and this is basically part 2. In the first part, I have discussed basics of sets, bounded of set, unbounded, supremum, and all. In this particular video, we'll discuss Archimedean property, open set, closed set, limit point, derived set, Bolzano-Weierstrass theorem, closure point, dense set, boundary point, and interior point. It is helpful for IIT JAM, GATE, and CSIR-NET. My name is Manoj, and I'll start the video. For the real analysis basic course or for higher studies mathematics, you can follow my YouTube channel MS Maths. You can like, share, and subscribe to your friends. So let's start the video. So in the very first, we'll discuss Archimedean property of real number. So what Archimedean property says that the set of natural number is not bounded above, or for x belongs to real number, there exists n belongs to natural number such that n greater than of x. It means it is nothing but the definition of bounded aboveness. Bounded aboveness means that there exists at least one real number which is greater than from all the elements of the set. So basically this is the thing. Whenever we will have natural number set, it will starts from 1 goes up to infinity. Okay, it has no upper bounds, so we can't say that it is upper bound set. So set of natural number is a bounded, unbound, like we can say unbounded above. Okay, not bounded above means unbounded above. Okay, so for here, from any two number, we can say for any two number x and y such that x greater than 0. Okay, if x greater than 0 and x and y are two numbers, then there exists some natural number and belongs to n such that the multiple of, like we can say, wait 1 second, it is not xn, it is n into y. N into x, sorry, is n into x greater than y. It means the n multiple of that n will be greater than of y. It means whenever you have this kind of thing, x and y, x is greater than 0. If I will multiply with n, which is n belongs to natural number, then nx will be greater than of y. Okay, this is the one of the property says in the Archimedean property or Archimedean property of real number. Okay, now some application we have, basically we can prove it. Okay, and proof is not required here. I'm not going to prove, it is the result. Okay, so some applications of Archimedean properties here we'll discuss one by one. Okay, so very first is that if, okay, first one, so if x is greater than 0, then there exists, if x is greater than 0, then there exists n belongs to natural number such that, okay, such that 0 less than 1 by n less than x. It means that whenever you have x greater than 0, it means 1 by x will be belonging from R. Okay, so in this case, there exists n belongs to real number, n belongs to natural number that we have discussed already, such that n is greater than of 1 by x. Okay, n is greater than of 1 by x. It means 0 less than 1 by x, or we can say 1 by n. Okay, this is 1 by n and this is x. This property will hold, while 0 less than 1 by n always, like, because in natural number, like see, 0 less than 1 by n. Why? Because of that, my n belonging from natural number, and natural number starts from 1. So of course 1 by 1 is greater than 0. Okay, so this property will hold. This is the one of the property, one of the application of Archimedean property. So using that we can see. Second, if x is less than equals to 0, or sorry, greater than equals to 0, if x is greater than equals to 0 and x, okay, and we can say if my epsilon greater than 0 and epsilon greater than 0, or we can say for all or for any, not for all, for any, and for any epsilon greater than 0, then x will be 0 when my x is less than epsilon. Okay, if my x is less than epsilon and epsilon is greater than 0, then we will say that my x will be 0. If x greater than 0 and if x is equals to 0, so this is the thing. If my x greater than, okay, one thing is there. If my x is not equals to 0, then it means that x is greater than 0, and it implies that n belonging from natural number such that 0 less than 1 by n, that we have already proved. Okay, but this is the contradiction, shows that it's the this contradicts where my x is less than epsilon, so it means my x is equals to 0 here. If my x is not equals to 0, if I will take that assumption that my x is not equals to 0, then it means my x will be greater than 0. But if my x will be greater than 0, then this property will not hold. Okay, so of course it must be 0. So these are the property we can prove by the Archimedean law. So this is all about Archimedean law. Now we'll move to next. So we have neighborhood. Okay, so we'll discuss neighborhood of point. What is the neighborhood? Neighborhood of a set we can consider, neighborhood of point we can consider, which is called also neighborhood of set. So basically a set of real number, which is subset of real number, is said to be neighborhood of a point x is equals to a if there exists any open interval I such that x belongs to I subset of a. Means a should contain at least one open interval, or a should contain open interval with respect to that particular point, then there exists a neighborhood. So it means for every epsilon greater than 0, there exists open interval of kind a minus epsilon and a plus epsilon. These all element must contain, if it is my I, then it should contain in that particular set. Then we can say that this will be the neighborhood of set. Okay, now we have some note points there. We will see. If a set A is subset of real numbers, does not contain an open interval, then A can't be a neighborhood of any real number. For example, we can see natural number. So in natural number, what is that? It is a discrete kind of thing, 1, 2, 3. While calculating the neighborhood, if I will take my A is equals to 2, is there 2 of epsilon or 2 plus epsilon whenever my epsilon is greater than 0? Is in this, or and one thing is that epsilon is belonging from the real number. Is it containing by natural number? Of course not, it will not containing by, it is not containing by natural number. So we can't say that it is there exists a neighborhood. So can be a neighborhood. Okay, can never be a neighborhood, sorry. Can never be a NBD, neighborhood. This is the thing. Similarly, Z. Okay. Similarly, integer, it also can be a can never be a neighborhood. Similarly, like rational number, same thing. Irrational number, same thing. Similarly, phi also. If my phi, it means it is what? The empty set. So there is no in empty set to subtract, to add. Of course, it can never be a neighborhood. Similarly, one thing, if I have some finite let's say finite set, that is a1, a2 up to an, then it can never be the same thing. It can't be a neighborhood. Okay, and like this is what any finite set, any finite set can't be the neighborhood. Okay, the set of real number is a neighborhood of any point of it. Of course, if I will choose any real number which is belonging from then a minus epsilon and a plus epsilon, it is nothing but the open interval, and of course it will contain by the real number. Similarly, open interval AB is neighborhood of each of its point. For example, if I will take I will take any point from this, or I'll like, let's say I can say my A belonging from this particular interval I. So I can find A minus epsilon and A plus epsilon will also contains in that particular I. Then it is what? It is the neighborhood. So this is the open interval. Similarly, the closed interval is a neighborhood of each of its point in open interval, but not A and B. If I will take, let's see, it is what closed interval. Okay, it is what closed interval. Let's say I will take x is equals to or A. Okay, then what I will do, x minus epsilon and x plus epsilon. It means what? A minus epsilon and A plus epsilon, but A minus epsilon is not in that. If I will subtract any small number from this A, it will goes up to like outside the interval. So it means it will not contain in the interval. So it is not. It is a it is a neighborhood on the open interval. It means where like while A and B are not the part of interval, then it is a neighborhood other than this A and B. Okay. Next is there is a property, so in which if n is a neighborhood of x and n is a subset of m, if n is a subset of m, okay, if n is a neighborhood of x, any kind of any point x, then n is subset of n, then m is also the neighborhood of x. Of course, if I have any set which is neighborhood of any point, if that set is a subset of any other point, that is also be a neighborhood. Okay, now the arbitrary union of neighborhood of real number, arbitrary union of neighborhood, you can say, of real number is again a neighborhood of that real number. Okay, arbitrary union will be real number, but it is what? Finite intersection, not arbitrary intersection. Arbitrary union will be again neighborhood, but finite intersection should be finite, which is the neighborhood is again a neighborhood of that particular point. For example, let's say I have this like intersection n is equals to 1 to infinite. Okay, it will be infinite, then it is what? 1 minus n plus 1, oh sorry, minus 1 second, 1 by n. If I will take intersection of this interval, minus 1 by n to 1 by n, it is what? Intersection is only the 0. Okay, but like infinite not. Okay, it means that it means it is not contained. So it should be finite. It should be finite, then after that it will be the neighborhood of that. So this is all about the neighborhood. Neighborhood is existing for a set, or a set be the neighborhood of a point if that contains the open interval of that A minus epsilon and A plus epsilon, then after it will be the neighborhood of that particular point. Now come to the open set. Open set is something related to the open interval. It means a set A is a subset of real number, is an open set if it is a neighborhood of each of its point. It means, let's say, it is a simple if in the simple word I want to say that, I can say if a set is a open set if it is containing the open interval. Neighborhood is what? The open interval. If it is containing the open interval, okay, for each of its element there exists an open interval. This is the another definition we can say. So now let's identify the open interval from all these things. Okay, yeah, for example, A belonging from I, which is also which is subset of A, then my A is also belonging from the set only. So there exists a epsilon greater than 0 for which A minus epsilon and A plus epsilon must be contained in that A, or we can say must be contained in I and it should contain in A. Okay, now for example, phi is what? Phi is an open set. Phi is an open set, but it can't be neighborhood of that. Okay, but this thing is very clear. Phi is an open set. Similarly, what about the natural number? Of course, natural number is not an open set. Okay, it is not an open set. Integer number, it is also not an open set. Okay, it does not contain any open interval. Similarly, this one is also not an open set. This one is also not an open set, but real number is, yes, it is an open set. Similarly, the complex number. Okay, let's say if I want to talk about the complex number, it is nothing but R cross R, and it is also, so this will be the open set again. Similarly, let's say any finite element, any finite set is there and belonging from the natural number, it is what? It is the finite set, then it is not an open set. Okay, singleton set is what? It is also not open set. If I will take 0 minus epsilon, 0 plus epsilon, which will not contain this by this set, so this is not an open set. Let's say it is what? 1 by n. Of course, it is not an open set because it is 1 by 2. What about all the elements in between 1 and 1 by 2? There is no. Okay, no like detail of that. So it means it is also not open set. So these are the example of open set and okay, open set and whatever closed set. Now let's see, we'll see the closed set also. So the properties are there. Arbitrary union of open set is arbitrary union of open set is open. Okay, arbitrary union of open set, it is what? About union must be arbitrary in that case. But while talking about intersection, it must be finite, not arbitrary. So arbitrary union is an open set, our finite intersection of open set is open, and arbitrary intersection of open set is not open set. This is very clear. Okay, next, closed set, a set which is not open, we can say it is a closed set, or we can say whose complement is open set. It means if I will subtract from real number, then it must be an open set, then we'll call that particular set is closed set. In this case, arbitrary union is closed. Arbitrary union of closed set is not closed. Okay, just see here. Here it is what? Arbitrary union of open set is open set, but arbitrary union of closed set is not closed set. Finite union of closed set is a closed set. Yes, arbitrary intersection of closed set is closed set, but arbitrary intersection of open set is not open set. Okay, this is the just opposite thing. Now we'll see. We'll see the examples related to this. For example, let's say I have an example is here. Okay, so minus infinity to a union a to infinity. Okay, a does not containing in this, a is not containing in the same. This is what? This is a open set, and this is also open set. If I will take union of both of these, then what will happen? It is a complement. It means a does not will be there. It means a complement, and a complement is what? Open. A complement is open. It means a, if I will take union, if I will take union, then this will be a complement, because a does not containing by this and by this. And what is a complement here? A complement is open. And what about a? Is closed here. So a singleton set is closed. So any, now this is what one of the case. Another case I can take another example. Let's say any finite set A is closed. Okay, this is what the singleton, and next I will take any finite element. So it is what? A1, A2, okay, up to An. Now I can write it as A1 union A2, okay, union up to An union. Now, what is the property of closed set? Finite union of closed set is closed set, and this is what we are taking, the finite union of closed set. Then it is, and see, this is singleton, this is closed, this is again closed. These all are closed, so we can say this finite union must be closed set. Similarly, we can take one more example. Let's say phi complement belonging from real number. Phi complement means complete. Phi complement not belonging. Phi complement means complete real number. So complete real number is open. It means that my phi is closed. It means phi complement is open. So it means my phi is closed set. This is what the property says of the closed set. I will take one more example. If I will take 1, 2 up to n, it is what? It is the same thing. It is a finite set and it is closed. Okay, that we have seen here. Next, if I will take example like this 1 to n and its complement, if let's say I will take its complement, it means that minus infinite to 1. Okay, there is no mention here that n belonging from natural number, so we can take like this. And union 1, 2, it means all the numbers in between 1 and 2. No need of, like here they have not mentioned in this example that n belonging from natural number. It means we can take in betweens like this interval we can make. If it is written like this and belonging from natural number, then we can't write like this. Okay, but here it is 1 and 2. Now union, and after that it is 2 comma 3. So it is what, these all are what, my open sets. If these all are my open set, okay, is open, these all are my open set, then this 1 comma up to n is nothing but closed set. This is what the thing, finite. Okay, this is the, the reason for that particular thing. And for the natural number, I can also write like this. So the complement of natural number is nothing but minus infinity to 1, union 1 to infinity. Okay, union 2 to 3, not 1 to infinity, 1 to 2. Okay, if it is open, then what is that? The complement of finite. The complement of natural number is what? The natural number, it means it is closed. Because of that, it is a countably infinite. So countable is also. So n is closed. So these all are examples. So we can take like some more example from here. So let's say to understand the concept in a better manner. Okay. So see more examples here. Okay. So for example, I have a comma infinite is open. Okay, is it open or not? Yes, is it open? How? A comma infinite is an open set. Let's say I will take any kind of, I can find any kind of interval. Let's say any a1 belonging from a comma infinite. If I will write a1 minus epsilon, a1 plus epsilon, for every epsilon greater than 0, this will contained by this particular set. Okay, it means, let's say it is my I1, then I1 will be contained by a minus infinite, a to infinite. Okay, this is the thing. Similarly, if we have, okay, if we have one more example we can take. Okay, if we have a comma b intersection q, it means that is what? It is my open, but intersection with what? The closed. It is not open as it does not contain any open set. This is the thing. If I will map, or if I will take intersection of this and this, Q does not contain any open interval. So it is not open. So it is not open. It does not contain any open interval. Okay, next. Okay, let's say if I will write like this, a comma b, if I will take intersection with irrational number, of course it is also not open. So the same reason for this, it's not containing the open interval. Next, limit point. Concept of limit point is also important. So a real number x is equals to 0 is said to be limit point of a subset of real number if every neighborhood of A contains infinitely many points of A. It is also known as cluster point. In that particular, in the neighborhood of that point, there must be present infinite many points of A. Another thing, if every neighborhood of A contain at least 1 point, what is the meaning of these both? There should, there, like basically we can say A contains, or the neighborhood of A contains, it means A minus epsilon and A plus epsilon for every epsilon greater than 0 must contain infinite number of element. Not must contain, it contains infinitely many point. If it contains infinitely many point, it means that there is at least 1 point present. There is at least 1 point in that particular neighborhood. So these both statements are correct. At least 1, not at most. At least 1, and what? At most it may be infinite. So these both statements are same. The meaning is same. Okay. Another thing. Third point we can say this is the same thing. Every neighborhood of this A, this is called the neighborhood of A, is representing like this neighborhood of NA. This is the neighborhood of A. Okay, an intersection with A. Other than that element A, it should not empty. It means if I will take intersection of neighborhood with A, other than that element, there must be at least one element. It means it should not phi. It should not empty set. So this is called the definition of we can say limit point, and we will see the example of limit point. So we'll find the limit point of certain examples here. So first of all, find the limit. Okay, limit point is means that if a point is like repeating in a particular set, we can say that is also a limit point for that. Infinitely time, if the repetition of that particular point is present in that case, in that set, we can say it is a limit point. And otherwise, this, definition is here only mentioned. That is something that it should contain infinitely many points, or at least one point in the neighborhood of that point. So find the limit point for this particular set. So for this case, if I will take anything, what is this set? Just see the behavior of this set: 1 by 2, 1 by 3, and going up to 0. One thing is that what is the what is at last, or what is the elements, what is the elements, or what are the element of set here? It will be 0.00001. Okay, 0.00001 will be here. So these points are will be here. It means that nearby 0, if it is my 0, this set will never achieve 0, but it is tending to 0. Nearby 0, there is a cluster making of that 0. What is this? It is nothing but approximately 0. It is also 0. So these both are equal at that point. So nearby 0, there is the cluster. It means if I will take 0 minus epsilon, 0 plus epsilon, in this interval, there are infinitely many points present in that particular interval. There are infinitely many points present in this interval. That's why this 0 is called the limit point of this particular set. Okay. Limit point is means that there exists an interval of, or we can say not interval, there exists a neighborhood, that is open interval basically. There exists a neighborhood which contain infinitely many points. It means there will be a cluster of points will be there. So approximate, these all are what? Approximate point, and this is going toward the 0. Not exactly 0. This is going toward the 0, and this is what making the clustering. This is the clustering there. So 0 is my limit point. So for this, limit point is equals to 0. Okay. Next thing. This is by Archimedean property, we can also find the limit point. Next thing. For 1 by 0, for minus 1 by n. So in the case of minus 1, it is what? Minus 1 by 2. It is what? Minus 1 by 2, minus 1 by 3, and it is increasing. Okay, it is increasing. So like it is increasing. So it is also going up to or tending to 0. Okay, this is what? 0 here. So again, it will make cluster near 0. It is not actually 0, but it is making cluster 0. Then it is what? 0 is the limit point. So this is what the limit point here. So the limit point of this set A is again 0. For this case, the same thing. Again, 0 is only the limit point of the set. Of course, it is going and it is making the cluster nearby 0 only. So again, the same thing, 0 is also the limit point. So this is what? The limit point of this. So these are the examples. We can have also, we can take one more example here. Let's say if my set A 1 by n, where n belonging from natural number other than 0. Okay, other than 0. Then what is meaning of this? It means it is plus minus 1 by n. And of course, it is also tending to 0 as n tending to infinite and minus infinite, we can say. And tending to infinite, or let's say in the like right hand side, in the left hand side, right hand side, and the left hand side to the 0. This 1 by n tending to this 0. And of course, the limit point for this is also, the limit point is going to be 0. The same thing. Okay, next. Now it is not necessary that like one thing. Now we are making what is the set, basically set of limit point. Now it is not necessary that limit point will be the unique for a set. And one thing is that limit point, it is not necessary that limit point is containing in that set. Okay, one thing is that. Next, the set of limit point is called as derived set, and it is denoted by a dash. Now, let's say example. So, for example, first we'll take just set, and what is the derived set for this? So, 5. What is the derived set? What is the limit point for the 5? There is no empty. It is what? This empty set. So, the empty set. So, these are the set here, and these are the derived set here. So derived set is 5. If it is natural number, then the what is the limit point? There is no limit point in natural number, so it is also 5. Okay. Next thing, z integer. There is also not we can say limit point, because there is no open interval exist. There is no neighborhood exist. So it means the set is also derived set. For q, there exists neighborhood, and the limit point is what? The derived set is what? Real number. It means that all the limit points of this q belonging from real number. Same for irrational number, it is also the real number, and for real number itself, it is a derived set of all limit point is belonging from the real number. Okay, one thing is. Another thing, we can take the example like this: 1 by n plus 1 by m, where m and n are belonging from natural number. So what is the limit point in this case? So the derived set, the limit point is basically, if I will take m fixed and n tending to infinity, then this will go to 1 by m. All the things will cluster towards the 1 by m. So it means it is a 1 by m. If I am going to fixing m, then the derived set will be 1 by m, where m belonging from natural number, other and also 0 be the case, because my m going to m tending to because here my n tending to infinity, and certainly my m may be the large one. Okay, m may be the large one. The case may arise here that m n tending to infinity and n tending to infinity, then what is this? It is the value to going towards 0 also. So we are taking the union of 0. Okay, we can take certain more example here so that the concept will get cleared. Okay, so yeah, this is the set A and its derived set. Now if it is 1 by 2 power m plus 1 by 3 power n, okay, 1 by 2 power n, and where n is belonging from natural number. So what is the limit point in this case? So limit point will be 0. If my n tending to infinity, these both will be 0. So the derived set, there is only unique limit point. So this is the derived set, and means set of limit point will be this. If it is like this, now see, if it is like this, 1 upon 2 power m plus 1 upon 2 power n, or we can say 1 by 3 power n, where n belonging to natural number and m is also belonging from natural number. Then in this case, if I will take, listen, if I will take from here, let's say my m is fixed. So in this case, what? The derived set is again the same thing, 1 by 2 power m and 1 by 3 power m, while n belonging from the m belonging from natural number, while m belonging from natural number. And certainly if these both will go to infinity, then there must be the unique the limit point will be 0 also. So we'll just write unique intersection, a union with the 0. There are many examples. We'll take one by one. Okay, for example, I have a set 0, 1. Then what is the derived set for this? Then derived set is what? The closed one. Okay, then 0 and 1 may include in that particular set. This is the derived set. So if I have AB, so this thing, if it is AB, then derived set is the closed set of AB. Similarly, if I have A is like this, 0 and 1, then what is the derived set? Then it is the derived set also itself. Okay, similarly, the same thing, if A is equals to AB, then what is the derived set in this case? So it is AB also. Okay, let's see if my set is sin n, where n belonging from this, then this is what? It is taking -1 and 1. What is this? Now you can feel the limit point, how many times sign will take -1? How many times sign will take +1? Infinitely time, if my n is belonging from natural number. So it means -1 and 1 are like repeating in that case, and in between all the values are repeating because these are periodic function. So the derived set is what? -1 to 1, all the values are on the repetition. Similarly, a is equals to cos of n, where n belonging from natural number. The same thing is here. The derived set is also -1 to 1. So these all are example of like a derived set we have taken here. Now next thing. Now next we'll go to the next. Okay, yeah. One thing is that a finite set A. I want to write some note here. Then I will go for the Bolzano-Weierstrass theorem. This is one of the important theorem. So note point. So first one, a finite set A is subset of real number has no limit point. It means the derived set will be empty. Finite set is no limit point. Okay, then the derived set will be empty. Second one, a set A is subset of real number is closed. If it is closed, if and only if its derived set is subset of A. Okay, if and only if. This is the thing, if and only if derived set is, for let's say this is what? Closed set. Okay, if it is closed set, then see this A dash containing A, subset or equal, same thing. Okay, this is the case. Okay, see, it is what? Open set. But here A dash does not contains by A. Is not. Is what? That's why it is open. This is the result here. You can see. Next, third result is say that a set A is subset of real number is closed if and only if it contain all of its limit point. This is what the second point. The same thing. If it is containing its derived set, or if it is subset, derived set is a subset of that set, then the set is closed. Or another thing, if it is containing all its limit point, and it is what? It is called the derived set. Derived set or set of limit point. Okay, it's the same point here. So for example, so find the closed set. We can see, we can take an example on the standard set. Okay, we have some sets here: phi, natural number, integer, okay, rational, irrational. See, is it a closed door? So in this case, let's see, is it a closed or not? It means A dash contained by A or not. So what is the derived set of phi? So phi is containing by phi, then it is closed, yes. What is this? It is phi. Phi is containing by natural number, then it is closed, yes. What is the derived set? Phi is containing by integer, closed set. What is the derived set is? We have seen it is what? For Q, the derived set is real number. See this. And for rational number, it is also this. So it is what? Real number is subset of, real number is containing in Q. No, so it is not closed. Similarly, real number does not contain by irrational number. It is not closed. But here, real number is contained or it is equals to real number. It means it is what? The closed set here. Okay, this is all about the closed set. Now we can take another example so that we can easily find, which we have also find the derived set. Okay, let's say one thing. Wait. Yes. Let's say I have a set of 1 by n. We have also calculated set is 1 by n, where n belonging from natural numbers. So what is the derived set? Derived set is 0 for this. Okay, derived set is 0. But see, Is 0 contained in 1 by n belongs to natural number? No, that's why it is not closed set. Similarly, if I will consider as like this, if a set is like this, 1 by n, where n is belonging from natural number. Now, see here in this set A1. Now, 0 is containing in A1, then it is closed. If there is a 1 by n, if a set is defined by 1 by n and 0 is in that particular set, if we make like this, then this is a closed set, otherwise it is not closed. This is the thing. Similarly, if I will take a set A2, for example, 1 upon 1 by n, where n belonging from natural number, then limit point is what? The limit point and the limit point is 1 and the derived set is 1. Is 1 contained by this set? Is there 1 contained by this set while taking n tending to infinity? But the thing is, 1 does not contain by 1 plus 1 by n. Does not. It does not. Okay, it means that it is not closed. If I will take union of 1 with this, then it will be a closed set. So this is all about that. So A is closed if and only if it is like this. So there is a theorem. So we have a theorem that is the result we have also written. So A is closed if and only if A dash subset of A, or in another word we can say A is closed if and only if A complement is open. Same. These two results are, let's say, these two results are very, very important, and this is the theorem. Now come to the next point. We have some another result or some another theorem. Okay, after that we'll go to the Bolzano-Weierstrass theorem. Let's say I have A is subset of B, then derived set of A is subset of derived set of B. Okay. Similarly, A union B derived, or the derived, we can say that set of limit point of A union B is equals to the set of limit point, or the union of set of limit point of A and B. Okay. Third is what? A intersection B, or its like set of limit point is subset of A intersection B not equal. It will be subset of this. For example, if I have A 0, 1, then what is the derived set of this? It is 0, 1, close interval. If I have B 1, 2, then the derived set is closed 1, 2. Let's see if I will take A intersection B. What is this? A intersection 0 to 1. A intersection, nothing is here in this. But if I will take the intersection of, A and this is what? 1 will be there. Okay, 1 is there. Now you can see it is 5 and it is 1. It is not equal. Let's say one thing is that if it is, wait. Yes, now you can see here. If I will take the derived, okay, what is the derived? See, what is this? What is the derived set? It is 5. Now you can see A intersection of derived set, okay, is not a subset of 1. So this can't be true here. Okay, so this is the thing, it can't be equal. This is a subset, not equal. Next. Whenever we will have this, okay, derived set closed if it is containing the derived set, let's say we have some, okay. Next result is related to this. Next result, we have some more result. The sum of two open set is an open set. The sum of two open set is an open set. This is the result. Okay, I'm not going to prove this. If, let's say, next, another result, if A and B are the subset of real number and one of them, A or B, is open set, then A plus B is open. Okay, and also same thing if one of them, or if both if both A and B are closed, then A plus B is closed. This is the highlight point. Here it is what? A or B. Here it is what? A and B. Okay, just highlight this point. Here, if these both are closed, then no, like then that is okay. But here, these both must be the closed. Then after A plus B is going to be closed. Okay, this is all about the limit, basically the limit point and all. Let's say next we have some more results are here. If A and B are compact, compact means that closed and bounded, compact set, then A plus B is compact. Why? A and B are compact means A and B are both closed and bounded. So of course A plus B will be the closed and bounded. So this means that closed and bounded. Okay. See, if A is compact and B is closed, one more result is there. If A is compact, okay, and B is closed, then A plus B is also compact. If both are compact, then the sum is also compact. But if anyone is compact and another one is closed, then it is also, then A plus B is not compact, then it is closed. Then it is closed. Sorry. Then it is closed. It means it is A is closed. The simple thing. Compact means A is closed plus B is closed. If these both are closed, then it is what? It is a closed set. This is the simple thing is here. Okay. Next we have Bolzano-Weierstrass theorem. Bolzano-Weierstrass theorem says that every infinite and bounded set has at least one limit point. Every infinite and bounded set has a limit, at least one limit point. Okay. For example, consider the following subset of real number. Let's say E is a subset n upon n plus 1, where n belonging from natural number. Okay, what is going to be the derived set of this? If I will take like this, it is what? 1 plus 1 by n. If n tending to infinity, then it is going to 1 as n tending to infinity. Then the derived set is only 1. Another thing is that, is it containing 1? Is it containing 1? If I will take, what is the least value in natural number is 1. 1 upon 1 plus 1 is 1 by 2. We'll start from 1 by 2. So it means 1 does not contain by E. It means the derived set is not contained by E. It means it is not closed. And whenever you have 4 option here, so first option is given like this. Let's say first option is given like this. E is okay, yeah, there is one more in the question. There is one more set is given F, that is 1 upon 1 minus n, where n is 0 to 1, not 1. Okay, in this case, what we can do? 1 minus n plus n, 1 minus n, it means it is what? 1 plus n upon 1 minus n. Again, if n tending to infinity, the derived set or the limit of this f dash derived set will be 1. The same thing will going to be here. But it is 0 to 1, not, sorry, not tending to infinity. Let's say the thing is 0 to here, na? So if it is 0 less than n less than 1, okay, then I can just write what here it is 1 upon, or we can say 1 minus, no? So it is minus 1 less than minus n less than equals to 0, or not, this is not equal, this is less than. Okay, then it is what we can just write like this: 0 less than 1 minus n less than equal 1 here. Okay, we'll just subtract from